All right, let's get right into it. We're going to talk about something that is absolutely critical if you're building AI systems that people actually have to rely on. We're talking about evaluation, evidence, and repeatability. This is all about how we move past just saying, hey, that looks pretty good, to actually proving that a system is dependable. So imagine this. You've got your new AI system, you run it once, and out pops a result. What's the very first question pretty much everyone asks? It's this, right? Is this output correct? And honestly, it feels like the most natural place to start. But what if I told you that's actually the wrong question? I know, it sounds counterintuitive. But for any system that's going to have real-world influence or take real actions, starting there is not just insufficient, it's downright dangerous. And here's why. Asking that one simple question leads us straight into something called the confidence trap. You know that feeling, right? You see one or two really impressive examples and you think, awesome, it works. But that confidence, well, it can be a total illusion. Think about what's really going on here. A single success, or even a few, completely hides a system's variance. You have no idea how much its performance swings around. It's like judging an entire movie based on one great scene. It just creates this false sense of security. And here's the kicker. That false confidence becomes a massive problem as we give the AI more and more responsibility, or as a slide says, as its authority increases. And that word, authority, that's the whole game right there. Authority is the power for a system to actually do something, to have a real impact. You know, a bad movie recommendation from an AI? Annoying. A bad decision in a financial or medical system? That's a whole different universe of risk. And this visual here does a fantastic job of laying it all out. This is called the Lifecycle Lens. It's basically a map for understanding AI systems based on how much power they have, how much risk is involved, and how easy it is to hit the undo button. Over here on the left, you've got what's called Assistive AI. Think of these as your helpful sidekicks. They're read-only, their suggestions are easy to ignore or reverse, and the blast radius, if they mess up, is pretty small. A mistake is not going to bring the house down. But then, you cross this line, the authority boundary, and suddenly you're in the world of operational AI. Now these systems have real power. They have a measurable impact. They might even be regulated, and reversing their actions, way, way harder. The stakes are just infinitely higher over here. And this quote just nails it. This is the core idea of this whole framework. The problem isn't AI technology itself. The real danger is giving a system unbounded authority, power that hasn't been carefully controlled, limited, and verified. So, how do we build those controls? How do we grant authorities safely? Well, we have to make a huge mental shift from anecdotes to evidence. We have to stop relying on our gut feeling that the AI is good and start demanding objective, cold, hard proof. And this chart makes that difference crystal clear. Confidence? That's subjective. It's a feeling. Evidence, on the other hand, is observable. It's a fact. Confidence comes from a single story, an anecdote. Evidence is built from repeatable, auditable data. One is basically a guess. The other is the only foundation for making a real decision. Which is exactly why this matters so much for any real-world deployment. You can't have a formal governance process, the group of people who have to sign off and say, yes, this is safe, running on feelings. Without evidence, any approval is just a shot in the dark. It's a complete guess. So this focus on evidence leads us directly to the real test for any system that wields authority. And that test is called repeatability. This is the one concept that truly separates a cool science project from a production-ready, trustworthy tool. So, what do we mean by repeatability? It means the system's behavior isn't just random chaos. It has to be predictable. It needs to stay within guardrails, within boundaries that you have defined as acceptable, and it has to do that over and over and over again. Now, here's a super common misconception. People hear repeatability and they think determinism. They're not the same thing. Determinism means you get the exact same output every single time. Repeatability just means the behavior stays within an expected range. And this is huge because it means that even probabilistic systems, like most of the big AI models today, can and absolutely must be made repeatable. So let's bring it back to our lifecycle lens. Real evaluation isn't about running the system once and putting a single dot on this diagram. No way. It's about running it again and again and again within a specific phase and collecting all that evidence to prove its behavior is staying inside those predictable bounds. Okay, so that all sounds good in theory, right? But how do we actually make this happen? How does this change the way we build and manage these systems day to day? It really boils down to discipline. It means you have to design for evidence from day one. First, you create your evaluation plan before you even think about deploying, not as some last-minute check. Second, you collect that evidence on purpose with a clear strategy, not just cherry-picking the good runs. And third, you make your acceptance criteria totally explicit. What does good enough actually look like? Write it down before you start the test. So what's the big takeaway here? What does this explainer authorize you to do? It gives you a new vocabulary, a new framework to engage with your governance teams using hard evidence, not just hand-waving in demos. It does not authorize you to deploy anything. It authorizes a more rigorous, a more professional process. Let's wrap up with this, because it says it all. This is how you stop hoping your system works and start knowing you can trust it. Trust isn't something you can just guess your way into. It has to be earned through the disciplined collection of evidence that proves your system behaves predictably. So I'll just leave you with this one question to mull over. When you look at the work you're doing, at the AI systems you're building or using, is your evaluation process really built on a solid foundation of evidence? Or are you still maybe just a little bit relying on a guess?